Okay, we already have this result from the information gain. So we call this is the decision tree. So this is the decision tree based on the information gain, and we need to do for every of these attributes to get this decision tree. For the splitting criterion, so there are some splitting criterion based on the attribute types. So the first is we call it, this is the splitting criterion when the A is discrete values. For example, I have the attribute color. Maybe this is related to the maybe fashion or other things. Okay? So we know that color, there are many values. Okay? So it can be red, it can be green, it can be blue, purple, orange, and so on. So for every of these brands, it is the branch for each of the value. One branch is grown for its known value of A. Let's say income. Okay, maybe we can distinguish the income into three: low, medium, and high. And yeah, each brand is the value. Now, if we have the attribute for the case B, if the attribute is continuous value, so continuous value means numbers. If it is numbers, let's say income, we can say the income in numbers, maybe 60,000 US dollar, 50,000 US dollar, 80,000 US dollar, and so on. Then, when we want to create this kind of split, the two branches are grown corresponding to A is less than the split point, and then the A is higher than split point. So for example, this one, I know the income and I can select this is less than or equal to 42. The other split is higher than 42. What about the other types? In this case, it is a discrete value, okay? And we need to create binary tree. Do you know binary tree? We call it binary. It means we have two. So the option, there will be only two, yes or no. If we have a lot of values, for example, the color, we have many colors: green, yellow, orange, red, blue, and so on. So we will limit. Is the color red and green? Yes. Then it will go to this branch. If it is no, then it will go to this branch. So when we are dealing with the attribute selection, there are some alternatives. We learn about the information gain. So this section we will learn about gain ratio. It is for the attribute selection in the algorithm name C4.5. Information gain, the previous methods that we use, it is biased toward attributes with large amount of values. What does it mean? In the previous example, we have only 3. So the age, we have only 3. Less than equal to 30, and then 31 until 40, and then higher than 40. What about if we have a lot of values? For example, in color, I have blue, red, brown, black, white, purple, yellow, and so on. So there are many values for the color. Information gain will be biased if we have large number of values. So if you have a lot of values like this one, it will be biased. So there are some authors, there are some researchers, they propose the gain ratio, and it has been used in the algorithm named C4.5. It is to overcome the problem of the bias. The idea is to use the normalization to the information gain. How can we do this one? Yeah, they have the split info. What is the split info? Yeah, we will check. And after we have the split info, we will make a new ratio. We call it gain ratio. So this is an example. Let me use the income. Okay. Let me use the attribute income. So in the attribute income, we have low, medium, and high. So how many low? 1, 2, 3, 4. How many medium? 1, 2, 3, 4, 5, 6. How many high? 1, 2, 3, 4. Okay, so we have 4 low, 6 medium, and 4 high. Then the idea is we need to do the calculation for the split info with respect to the attribute income minus 4 divided by 14 multiplied by log base to 4 divided by 14. This is for the low. And then we have this formula 6 divided 14 multiplied by log base to 6 divided 14. This is for the medium. And 4 divided 14 multiplied by log base to 4 divided 14. This is for the. So we get the split info is 1.557. In order to get the gain ratio, so do you still remember this one? This information is from the information gain, from the previous one. When we get the gain for the its attribute, we got the value 0.264. When we get the income, the value is 0.029. For student, we have 0.151. So we will do this one. We need to get the gain ratio. For example, this is only for income. For the income, the gain, the information gain is 0.029, and it will be divided by the split info, which is 1.557. So we get the result 0.019. We need to do the same. We need to calculate the gain ratio for each. We need to get the gain ratio for student, and we need to also get the gain ratio for credit rating. We need to calculate all, and then the attribute with the maximum gain ratio is selected as the splitting attribute. Okay. We need to check the maximum. We have another way to do the attribute selection. We call it the Gini index. What is the Gini index? We have the CART. CART, it means the classification and regression tree. Okay. So this is one of the famous algorithm. Sometimes we call it the IBM intelligent miner. In this Gini index, if there is a data set D, okay, we have D is a data set, it contains examples of n classes. So the Gini index or Gini T is defined as like this one. We have 1 minus by the probability of j power of 2, and we will do the summation for j from 1 until n, where Pj is the relative frequency of class j in D. And we will create the data D and split it into two subsets, D1 and D2. So the Gini index D will be defined as this one. So this is the Gini attribute A for the D data set. D1 is the splitting one and D2 is the splitting two. And at the end, we will do the reduction in impurity. The attribute that provides the smallest Gini split, this one, or the largest reduction in impurity, or this is the largest reduction in impurity, it will be chosen to split. Okay, so in this, to enumerate all possible splitting points for its attribute. Okay, what does it mean? Let's see examples. So we use the same examples here. We have the 9 tuples of pi computers. 9 tuples of yes and 5 no. And the Gini T will be 1 minus 9 divided by 14 power of 2 minus 5 divided by 14 power of 2. So this is the Gini index. And let's suppose the attribute income partitions D into D1 and D2. So we have only two sets. Okay. In this case, we need to have only two sets. How we can make two sets? We need to combine some values. If there are three values like low, medium, and high, then we will make low, medium, and high, and then we can make medium, high, and low, and we can make low and high and medium. So we need to calculate for every possibility. We call this is D1 and we call this is D2. And we can make the count matrix. We call this is the count matrix. The count matrix, the low, medium. Low and medium means medium, low, 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 medium, low, medium, 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 medium. Now we need to check how many yes. 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 of yes, and how many no? 1, 2, 3. We have 3 no for low and medium. What about the high? 1, 2, 3, 4. And among the 4, how many yes? We have 1, 2, for yes. And how many no? We have 2. 1, 2. After we have this count matrix, we can calculate the Gini index. How we can calculate this one? The Gini income where the D1 is low and medium, then we have 10 divided by 14, which is the total data, multiply with the Gini D1, and then 4 divided by 14 multiply with the Gini D2. So the Gini D1 is this one. Gini D1, it is obtained from the 7 yes and 3 no. And then plus 4 divided by 14, we have the Gini D2, it is from this one. 2 divided by 4 plus this one, 2 divided by 4. So if you calculate this one, then you will get the value 0.443. As I mentioned to you, we need to calculate 3 possibilities. Okay, the first will be low and medium, and then high. So the second is the medium and high, and we can get the D2 is low, and the other is low and then high, and the D2 is medium. So here we get the medium high 0.45, and we get the low high medium, which is 0.458. And among this one, we need to get the lowest. What is the lowest? This one. So we say that this is the splitting. Okay. So the split will be the split will be low and medium for the left, and then in the right it will be only high. Okay, so we have only 2 branches. Okay, all attributes are assumed continuous value. Sorry, I'm wrong. This one. All attributes assume categorical values. Okay, discrete values, because this is discrete. Okay, so all attributes should be categorical, not continuous. Sorry. And you need other tools, clustering, to get the possible split values if it is continuous values. Okay, so this is wrong. Okay, I'm sorry. I need to update this one. Now, how if we have continuous value? If we have continuous value attribute, let attribute A is continuous value. So we must determine the best split point for A. Let's say if I have the A is salary. So we need to know what is the best splitting point. Let's say if this is the distribution, or this is the distribution, or this is the distribution. So how we can select the best splitting point? The idea is, we need to sort the value in increasing order. Typically, we will check the midpoint. So we will check the middle point between each pair of the adjacent value, and it is considered as the split point. So the split point means the AI plus AI plus 1 divided by 2. So we will check that on this one. And the point with the most discriminating power is selected as the splitting point for the attribute. When we do the split, we can use the idea of the Gini index. In the Gini index, we have D1 and we have D2. So the D1, let's suppose we have the splitting point, so it is less than equal to the splitting point. If D2, then it is higher than splitting point, then yeah, we can distinguish into two, D1 and D2. In order to calculate this one, we can use some binary decision based on one value. Actually, yeah, we can do something like this one. I have the information refund, marital status, taxable income, and cheat. Yeah, it means whether the person who get the credit, they will cheat or not. So refund means, yeah, there are some tax refund. Yeah. He got the refund, he didn't get the refund, he didn't get the refund, and so on. Marital status, single, married, divorce, and so on. Taxable income. So this is the income, 1 to 5K. 1 to 5K means 100 to 25,000. 100K, so it means 100,000, and so on. So this is the continuous values. How can we make this as the splitting? So there might be some choices for the splitting values. Okay. The number of possible splitting values is equal to the number of distinct values. So you can use every value. For example, now I use the splitting value 1 to 5. Then you will check if it is less than 1 to 5 and if it is higher than 1 to 5. Then you will check, is there any number below 1 to 5? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then is there any value which is higher than 1 to 5? Okay, we have 1. So we will calculate. And then after that, we will go to the next iteration. We will use the 100K as the splitting value. Is there any number less than 100K? Okay, we have 1, 2, 3, 4, 5. Is there any number higher than 100K? Yes, we have 1, 2, 3. Oh, sorry, this one is below 100. So we will do every numbers and do the repetition. Each splitting value has count matrix associated with it. And class count in each of the partition, we will have the less than or greater than, okay? Less than, equal, or higher. With this kind of idea, we select every number like this one. It is simple. If for each value, scan the database to gather count matrix and compute the Gini index. But it is computationally inefficient. Here we have only 10 data. But what if we have 1 million data? So if we need to check for every numbers, so it's very computational high. Because it is repetition of work. So that's why there's another way to compute. So we want to check for every of these attributes. First, let's sort the value. Sorting. And we can do linearly scan these values, each time updating the count matrix and computing the Gini index. Do you know the meaning linearly scan? If you learn in the data structure and algorithm, you will have the big O and the linear is N. It means you will have the amount of data as your computational. It means there is no much computation. The computational performance is not that high. And then we need to choose the split position that has the least Gini index. So let's see. we want to sort the value. Okay, we have 1 to 5, 100, 70, 120, 95, 60, and so on. So we want to sort the value and like this one. The minimum is 60, and then 70, 75, 85, 90, 95, 100, 120, 135, and 220. Now, we need to check the split value or the splitting position. Since 60 is the lowest one, yeah, we can check also like this one. Okay, this is the cheat is no. This one is the cheat is no. Okay, this is no. Yes, yes, yes. No, 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 no. Okay. So somehow maybe we can, yeah, check this kind of pattern. Okay. The yes is most likely in the middle, but we still do not know. Okay. This is just our prediction, our just from the visualization. So we need to check based on the splitting position. Let's say we have 60, so I put the value 55. Okay. After I have the value 55, so I need to check how many yes if it is less than equal to 55. How many yes and no, because this is count matrix. And how many yes and no if it is higher than 55. Let's see. The minimum is 60. So less than equal 65 will be 0 and 0. What about higher than 55? Yes, yes, yes. So there are 3 yes. What about higher than 55 and the class is no? Then we have 1, 2, 3, 4, 5, 6, 7. So we have 7 no. Using this one, can you calculate the Gini index? Okay, so we already did from the previous example. You can get the value 0.420. Now let's move to the next value, which is 70. This is the second smallest value. In order to get this value, then we can just make the midpoint. The midpoint will be 60 plus 60 is the minimum value, and the next consecutive value is 70. So 60 plus 70 divided by 2. Then the result is 65. So 65 will be the splitting value, and we will put it here. So now I would like to check how many yes and no if it is less than equal to 65. And how many yes and no if it is higher than 65. Less than 65. Okay, we have 60. Okay, this no. Then there is one no. What about this? More than 65. More than 65, we have yes, yes, yes. Okay, we have 3 yes. So I guess this is the remaining because the total is 7. So we have 1 and 6. Again, we can calculate the Gini index. Now we can also calculate the next value. We have 75. So we can calculate the midpoint. The midpoint will be 70 plus 75 divided by 2. The value will be 72.5. So we use this value as the splitting point. Just for the simplicity, I round up the value into 72. So we can again do the count matrix. This is the count matrix. When the yes, when it is less than or equal to 72, yes is no, 0, and no is 2. When the value is 72, so higher than 72, we have 3 yes and we have 5 no. So we can calculate the Gini index. So we calculate for every possibility of this one, and okay, we get the minimum. The minimum is 0.3. Then we can say that we can use this number as the splitting point. So if we have attribute taxable income, okay, then I can split. This one is less than equal to 97K, and the other split, oops, the other split is higher than 97, something like this. Because 97 give you the least value of the Gini index. Okay. So we can compare these attribute selection measures that we learned until now. There are 3. We have the information gain, and we have the gain ratio, and we have the Gini index. The information gain is to get the maximum value. The gain ratio is to get also the maximum value. For the Gini index, we want to get the minimum value. So there are 3 measures. Okay. In general, it returns good results, but the information gain, we know that it is biased when we have multi-values attributes. So for example, the color, if we have a lot of colors, yeah, green, blue, red, yellow, and so on. So if there are many colors, yeah, it is biased. Gain ratio. Gain ratio is the improvement of information gain, but it tends to prefer unbalanced split in which one variation is much smaller than the others. So there will be some imbalance later when we create the decision tree, when also the value is allowed. How about the Gini index? The Gini index, it also creates 2 split, okay, left and right, and it is also biased to the multi-value attributes. And it has difficulties when the number of classes is large. Now we have only very small classes. Yes, no. Okay, so only 2 classes. In my research, so we want to classify the human activity in Gantungjang. So when we deal with the human activity, there are many activities. For example, we want to recognize the person is playing basketball, soccer, nonggu, cuku, danggu, and many things. So there are a lot of activities. So last time we have 400 activities. Yeah. With the Gini index, it is impossible because too many activities. And thanks to favor tests that result in equal size partition and purity input partitions. So if we have the splitting with this Gini index, there will be some equal size in most of the time. So sometimes it is not good as well. So there are other attribute selection measures. Like this one, shape, okay, C shape, okay, and G stats, MDL, multivariate splits. I cannot explain one by one. Okay. Now you already know at least 3 kind of attribute measures. Based on those one, yeah, you may have questions. Which attribute selection is the best? So most give good results. None is significantly superior than others. It means it depends on your data. It depends on your objective. It depends on the number of values. It depends on the number of attributes and many things. So we cannot say the decision tree with the information gain is the best. Maybe your data set should use chain because of the a lot of attributes. Maybe your data set should use MTL and etc. So you need to check. That's why when we do with the data mining on the machine learning, there should be the comparison with other algorithms. Okay, learning check. What are the 3 possible methods for attribute selection in the decision tree? We have information gain. We have gain ratio. We have Gini index. Okay. For the information gain, we need to get the maximum value. For the gain ratio, we need to get the the maximum value. For the Gini index, we need to get the minimum value. Okay. Can you briefly explain on how to split continuous value attribute? When we have continuous value attribute, the simple explanation is first, we need to sort the values. Okay. First, sorting. After we sort the values, we need to determine the mid values between 2 consecutive values, and then create the count matrix and calculate the Gini index. Okay, as I explained to you, we need to set the mid values and then create the count matrix. We will check how many yes and no when it is lower than the mid value. And then we need to calculate how many yes and no when the value is higher than the mid value. And then calculate the Gini index. At the end, choose the least Gini index. Okay. Can you briefly explain on how to split discrete or categorical value attribute? If you are using the continuous value attribute, you need to sorting the value. But for the discrete or categorical value, you don't need to split. So the first, you need to make the count matrix. Okay, so in the first part, we learn about the count matrix. We need to say the age is less than 30. So how many yes and how many no? So we can make the table. After we have the count matrix, so we can calculate what is the measure that we want to use. Maybe you want to use the information gain, and then you can also perform the gain ratio, or you can perform the Gini index. in the terms of Gini index, you need to determine only two split, D1 and D2. Okay. And then last one, you need to select the attribute. If it is information gain, then you need to select the maximum. If it is gain ratio, you need to select the maximum. If it is the Gini index, you need to select the minimum. Okay. Okay, any questions? Okay, then I think due to the time, I need to have more time to explain this one. Let me explain this on Tuesday. Okay. So now you can